Good morning, pre-calculus. Today we get to look at section 10-5. A little more rigorous work in this section. What we're going to look at is rotation of conics. We're going to do two different things in this section. So if you follow along with me, I'm certain you'll have no problem. So if we go back to the previous four sections, at the beginning of the chapter, section 10.1, we talked about this equation right here. This is the equation of a conic section. But if you remember, we did not focus on the bxy. They took it out because we just focused on that conic section, and we realized that the A and the C will tell you what type of conic it is. Will it be a parabola? Will it be an ellipse? Will it be a circle? Will it be a hyperbola? That will tell you. But now what we're going to do now is we're going to introduce this into this equation, because that deals with taking a conic and rotating it. So in other words, instead of dealing with a up or horizontal or vertical, now we're going to take the conic and rotate it. Okay? Rotate it by a certain amount of degrees. But now we cannot use the same rules that we did for section 10.1 to 10.4, because here it may give us an indication that our conic does look like to be a hyperbola, but it could be something else. Okay? Or the conic may say here that it is a parabola, but it may be something else. So what we have to do is we got to add something else into the equation that deals with the discriminant. We'll talk about that when the time comes. And the only way I can really talk about these type of problems is just by doing examples. I'm not going to do any outline form like I normally do. I'm going to have to hold you guys a little bit responsible for opening up this section and reading it. I will point out that when you get to some of the examples, they eliminated some portion of the problem because they didn't want to show all the work. I'll bring that to your attention when I get to it. So let's just start. I have three examples. I might do two videos, just give you guys an idea of one, give you an idea of what we're dealing with. The second video will probably be a little more complicated problem. I'll do that as a second video. So today, let's just do two of them. So let's start off with our first one. Let's write the equation of xy plus 2 in standard form. So what we're going to do is we're going to put this in standard form. What do I mean by that? We're going to put it in the form that will look like a conic, but it really is going to be a rotated conic. Okay? Standard form. You'll see it when we get to it. And then I'm going to show you how to do this on your calculator, how to graph this. Okay? Right now, we could not graph this using our calculator. We have to do another form. All right, so let's go at it. Okay? First thing first, we already know that in the standard form, there's no A and there's no C. Well, if we go back, if we had no A and no C, that will be a linear function. But this is not linear, okay? We're going to see what kind of function it is. When we get it into the standard form, you'll have an idea of what type of conic this is. All right, the first thing we're going to do is, if we follow the book, is we're going to identify that we know that A is 0, we know that B is going to be 1, and C is going to be 0. That has some significance, especially when we get into, if we focus on the discriminant, okay? I'm not going to go over that part. If you want to go to that part, it is on page 767. We can classify this conic based upon that table at the bottom of the page. And I can tell you right now that this, by description, tells us that it tells us it may be a parabola, but we'll see what it really is. Okay, we got to be very careful in these situations. So the first thing we're going to do is we're going to go and figure out what the rotation is. And to do that, we have to use the formula. The cotangent 2 theta has got to equal A minus C divided by B. So again, taking this part right here, we know A is 0, we know C is 0, and we know B is 1. So that means it's going to equal 0. So now the cotangent of 2 theta has got to equal 0. Now, going back, we already know cotangent is cosine over sine. So what we got to do first is, we're going to come back to this in a second. So the first thing we're going to do is, we already know that we're dealing with a cotangent, but the 2 theta has got to equal 0. So again, we got to ask ourselves on the unit circle, where in this case is our cotangent, in this case going to be a value of 0. So we have to go back to this guy, cosine divided by sine. So we got to ask ourselves from the unit circle, where is it that this is going to give us a value of 0? Well, we can't have, so we have to use pi over 2. That's 90 degrees. You'll see it. Go back to your unit circle. It goes all the way back to a previous chapter. So taking that now, 2 theta equals pi over 2, because we already found out what the cotangent of 0 is. Okay, it's pi over 2. So then that tells us that our theta equals pi over 4. So what it's telling us in this case, that this is going to be rotated 45 degrees. Not only is it going to be rotated 45 degrees, but it's also going to be rotated counterclockwise. Important. Okay? So, moving on. Now we want to get it into the standard form. So what we're going to do next is the second part. This part right here is all found in the rule on page 763. So we have to go in here. We have to assign x as and our x and y's to fit into this form. You'll see why. Okay, so setting it up, again, doing this here, again, you'll see it in the page. They give you the rule, the derivation of it. We're not interested in it. So setting it up, and then what we got to do is just use your unit circle again. So the cosine of pi over 4 is radical 2 over 2. Which is, you should know that by now, it's 45 degrees. The sine of pi over 4 is radical 2 over 2. And then the next thing we do is I went ahead and factor out a radical 2 over 2 on both sides. And now keep moving on. So now we've associated x and y as x prime, y prime. So that has to deal with the form of a conic. So now going back up here, here's our original function. So xy plus 2 equals 0. So now we already know x is this, and we know y is this. So we plug that in. And then we go ahead and do our algebra. The next thing I did is I did a little bit of let's see, did some distributivity. And actually multiplication and multiplication. So again, I took radical 2 over 2 times radical 2 over 2. That gives us 1/2. And then when you're left with x prime minus y prime times x prime plus y prime, that becomes a difference of 2 perfect squares. We'll keep moving. Subtract a 2 from both sides. All right. Again, the application here, this is distributed 1/2 to the 2 terms. Then we divided both sides by 1. Well, actually, what I did is I divided by -1. I got this set up. And then when you go and look at this setup, this right here is the form, the standard form of this equation dealing with a rotation. And if you look at this problem here, again, we got a minus sign here. So this tells you that this is going to be a hyperbola. All right. So again, there's other information I want to show you. Now, how would you show this as a graph? We already know this is a hyperbola. Again, it's going to be, and this one is going to be a vertical one. So in other words, it's going to look something like this. Again, how would we look at this as a rotated form? So again, this is something that you can do. It's really easy. If you take your original equation, and to graph it on your graphing calculator, it needs to be in terms of y. So if I take that problem and I subtract 2 from both sides and then divide both sides by x, I have it now in terms of y equals -2 over x. You with me? All right, here's our original problem. We know it's going to be a rotated function. Doing a little bit of algebra and the concepts of this section. We've got it into a form. We can see that from here, this is a hyperbola, but let's look at it graphically. Just taking our original function, putting it in terms of y. That's what we did here, okay? So again, if you go and turn your calculator on, y equals, right. Again, I had to use this earlier today, so I have to get it off of a form. So y equals -2 divided by x. Hit graph. Again, I used it in an earlier section, so I have to wait till I did it on another class, and I didn't go back and change this. So I have to go zoom, standard. And if you look at it, there it is. That's what that graph looks like. And if you notice it, like I told you earlier, okay, based upon this part right here, this is a vertical hyperbola, but now it is taken and rotated at 45 degrees. So this is what the graph of this rotated conic looks like. All right, all I did is I took all our information, figured out how it's rotated. 2, I put it into the form. Again, we look at the form here, we know it's going to be a hyperbola. To see it graphically, I took the function and I put it in terms of y. Okay? Now earlier, if we go back to your book on page 767, and if you look at the classification of conics by a discriminant, again, point number 2 tells us that if b squared minus 4ac equals 0, okay, well, what we can do is you can figure out what this is by taking this and put it in your discriminant. So again, if we go back, this is good help. So it's b squared minus 4 times a times c, which we get a value of 1. And based upon page 767, that discriminant is greater than 0, so that tells me that this type of conic is going to be a hyperbola. I did it algebraically. I applied the, I did it graphically, and then I applied it to the discriminant. All right, which is on page 767. All right, let's look at the next one. Like I said, I'm going to do 2 of these in this video, and then I might just do 1 video. All right, here's our next one. We have 5x squared minus 2xy plus 5y squared minus 12. Again, we could have just done the discriminant thing, get an idea of what this type of conic looks like, but in my original notes I didn't do that. So I'm just going to keep to what I have here in my notes. Okay, so what we want to do is we want to get it in the form. So we know that A is 5, B is -2, and C is 5. We can figure out what that is from page 576, but we're not going to. All right, the first thing we're going to do is see what the rotation is. Again, cotangent of 2 theta equals A minus C all over B. Again, we got a value of 0. So again, we know that the cosine, once again, cotangent is cosine over sine. So we got to ask ourselves, cosine over sine, what does that equal as a 0 on the unit circle? Well, we know it's pi over 2. So 2 theta equals pi over 2. Solve for theta, we get theta is pi over 4, so it has a rotation of 45 degrees. Not only is it rotated 45 degrees, but it's rotated 40 counterclockwise. All right. Now the next one is using all that information we did earlier. Now again, this one that I'm showing you is about as similar to example number 1 and example number 2 in your textbook. But I want you to, if I was to focus on example number 2, they stop at this stage right here. And they go in and avoided some of the other rigorous work, okay? I'll let you see that when you study. So again, going here, We keep going on. We plug. We know x is this, so we plug it back into the x's of the original function. Oops, I'm off the screen. We know that this is our x. We know that this is our y. So if we take that information and plug them in here, respectively, that's what I did right here. They do not show this in your book. They do not show all the details. I'm showing you the details. Okay, after all this, it's all algebra. All right. So again, I'm not going to go over and talk about this. I'm going to let you guys decipher this because you can do this another way. Okay, I'm just going to show you what it would be like if you had to do it algebraic and the rigorous way. So all this goes all the way down till we get to this part right here. I'll let you guys figure that out. I'm not going to focus on that because we can do this another way. All right, so if I divide both sides by 12, again, if you look at this part right here, we know that this is an ellipse. Also, we know that this is a squared. It's underneath the x term, so that tells me that this is going to be a horizontal ellipse. The right-hand side is some other information they'll probably ask you about. What is the vertices? You can grasp that. So we know that this is an ellipse being rotated 45 degrees. Again, other information to help you guys out. Like I said, this is a little bit new to you guys, all right? So let me show you how this would look like graphically in terms, I want to find what this looks like graphically using your graphic calculator from this. Okay, we already know just by doing all this, we've got it set up in this form. This, remember now, this tells me that this is a rotated conic. It's a parabola being rotated 45 degrees. All right, now how do I do this on our graphing calculator? Okay, first things first, you have to take your original function and put it in terms of y. Now this is new, okay? This is real new to you guys. What we're going to do is we're going to take this, and if you stop and look at it, this is really a quadratic equation. So what I'm going to do is I'm going to take that and treat it like a quadratic equation, because if we treat it as a quadratic equation, we can do and use the quadratic formula. You'll see why in a second, okay? It's a quadratic. I know it's a quadratic because I have a second term here and a second term here, but we're doing it in terms of y, so we're focusing on the y. The original one that we're used to was in terms of x. So what we're going to do is we're going to think of this function in terms of y. So we're going to take that whole problem and we're going to set it up like a quadratic. So all I did is I manipulated it so that the first term is a quadratic term, the second term is a linear term, and then this is your constant. So I'm just focusing on terms of y. So by looking at that now, we can tell ourselves, okay, a is 5, b is negative 2xy. I think I missed something, but no, it's just keep the 2x because that's your coefficient. The coefficient of y is negative 2x. And then your constant, which is 5x squared minus 12. So we take that, plug that into our quadratic, and we will get this. Okay? This right here is what we can do now for our calculator. It means two things. Okay, well, I think I went a little bit further. I combine like terms. Okay, so this is what we're going to deal with. We have two equations here. Remember now, this is in terms of y. So it's really simple, okay? Go to y equals. We have two equations. One of them is going to be plus. The other equation is going to be minus. So we go 2x minus. Again, I think I should do a parentheses here first. Parentheses, 2x plus the square root of negative 96x squared plus 240. Close that up with the parentheses and divide it by 10. There's your one equation. All right, do the next one. So we would have, close that up in parentheses, we'll have 2x minus the square root of negative 96x squared plus 240. Close that up with the parentheses and divide it by 10. All right, so all we got to do now is hit graph, let it think. There is the top half, that's the plus. The first one is your plus, and the second one is your minus. So you can see right there that one, again, the picture doesn't show it, but it's been rotated 45 degrees. It doesn't look like it, but it has, okay? So that is section, that's how you would do these problems. Now the part that's going to drive any of us up the wall is this part right here. This is all algebra. Once we find out what our rotation is, we find out what our x and y is in terms of the formula that they give you in the book, put it into your function. All that stuff is the algebra to get it to this part right here. So we have this guy right here. This is our main point. Again, just by looking at this, this is an ellipse. Yes, it is. We could have done it by the discriminant up. We could have done it by the discriminant up here. Then all this other information ties into this equation. The backside, I showed you how to do it using your graphing calculator in terms of y. We don't need you anymore. Now, the next one is the longest of the two, because the first two I showed you both had a rotation of 45 degrees. Now this next one, this one a little more difficult. Again, there it is. Again, a little more difficult. The hard part now is finding out what the rotation is. And that's this part right here. So I'm just going to go and show you guys this. I'm going to let you do it on your own. Again, if you look at here, we know that we have to figure out what the angle is here for 3/4. So what I had to do, what you have to do is go over here and treat it as a right triangle. Again, once again, this is your x value. This is your y value. In order for us to find this, we need to know what our r is. We did this in a previous chapter, and that will tell you how to figure out what theta is. And again, if you do your math, theta is going to be 25.6 degrees. I'll let you guys figure that out. This one's a little bit more complicated, a little bit more work. I am just going to show it to you. You're more than welcome to print it up and work it out yourself. A little bit more complicated. Okay, based upon this one is a parabola. Okay, now I did not work this one out. I don't think I did. Nope. If you go back and take this part up here and do it in terms of y, like we did in the previous section, treating it as a quadratic, you should be able to get your equation up, okay? So again, I'm just going to show you this part. Now I know years past I've always showed this work here. Again, if you just want to go and tie into the discriminant, get yourself an idea what the function is going to be like, find out what your angle is. So again, your angle all comes from this information over here. I'll let you, again, I did not show this to you, but if you go down here, theta is 1 over radical 5. It's in radians, so you can take your radians and convert it to angles, okay, or degrees, excuse me. So this one rotates 25.6 degrees. All right, now this, like I said, this section's a little bit different than all the other ones. This is relatively new to you guys. All right, I'm going to stop there. If you need any help, don't be afraid to call me. This one's a little bit more challenging, a little more rigorous than anything. Not challenging, just a little bit more rigorous. Again, I'll let you guys work this out. All right, thanks. See you guys in the next section. Bye.